Hi guys, so we've got the data into R using the previous example. This time we're going to show you how you can manipulate the data a lot more simplistically using a package called DPLYR. So the first step really is to install the package DPLYR. So we're going to look for DPLYR. We're going to use the install command. As we've seen previously, this goes through the installation process and then tells you if it's been successful. So that looks good, everything's white, so now we can then use that package in our script, in our environment, should I say. So bring that in first of all. Okay, I think that's okay. There's a few masked items there, but I think we should be able to use those. So what we're now going to do is look for a data frame that we can work with just to perform some data manipulation. Let's have a look. Should we use the cars data frame? Let's have a look at cars. So if I just run that, okay. Oh, it's speed and distance. So yeah, we can use that. Let's set that as our data frame. Okay. So that add that to a data frame. You can see now we've got 50 observations of 2 variables. Okay. So if I use a summary of that, it should give me some summary statistics. So the average speed and the average distance. It's not going to give us a whole host of fields to work with, but yeah, it will give us enough. Another command you can use is the dim variable, so dimensions. So if I run that, it basically returns the same values as here. So 50 observations of 2 variables. So the cool thing about DPLYR is you don't have to know about indexing and slicing notation, which we've covered previously in the start lectures. You can use things called filters. So I'll show you how this is achieved. So filter comes directly from DPLYR, and I'm going to use the DF data or the cars data, and I'm going to say with speed, so DF speed, that's how I like to refer to it, is equal to, let's have a look at the original data frame, where speed is equal to 4. So give me all those where the speed is equal to 4. So that will filter out. And as you can see, quite simply, we've not had to go through as many steps to get there as with using the subset function or as with using indexing. We can combine them together quite easily as well. We can now look at distance, so df distance, and I'll return those that are greater than 2. So I know that will then drop the first item here. So it only just gives me one result now, but you can just keep adding them on. You don't have to do and. You can pass multiple arguments. You can just keep going with it essentially. So that will create you a subset. So we could just say, we'll create a variable name so we can copy that. Speed 4 and dist greater than 2. Nice long name for a data frame. Name that, so that'll then create me another data frame here, just with one observation. Okay, so that's how you could use the filter command, and there's it's a lot simpler than working with a data frame. To replicate it via indexing, I'd have to do this, I think. I'd have to use my data frame, and then I'd have to go data frame speed equals, what did we use? 4. And then I have to use the and data frame distance greater than 2, and then I'd have to use the comma, because remember, if we're returning rows, columns after that, That's how we'd do it in index notation. So that would give me the same result as here, but that's a lot cleaner. So it's just filter, data, and then the arguments that you want to pass, as opposed to data frame and calling the data frame again, so each field at a time, using the operators to use an AND function, so that and that. I mean, it's a time saving, but it's not massive. There's also the slice command in DPLYR, slice command. So you can use these. Let's take a slice of our data frame and let's do 1 to 10, the first 10 items. So that gives me the first 10 items in the data frame, similar to how we used to slice before. If you can remember, data frame, and then we'd use the 1 to 10. Oops. Yeah, we'd have to use a comma afterwards, wouldn't we? Just remember that all the time. And that gives us the same result. But again, you don't have to remember what you're trying to return. It just will return whatever's in that data frame for you. It's the first 10 rows essentially. So yeah, that's how you use the slice command. There's also the arrange command, and that's similar to filter, but it applies a sort at the same time. So the arrange command. This time we can use arrange. You can see it comes from DPLYR. We're going to use the data frame, and we're going to just arrange by speed, df speed. So we're going to do a arrange on df speed. So yeah, what I've done is passed data frame, and I want to arrange it by speed. This will apply an ascending sort. So you can see that now speed is ordered based on the relative speeds. And then I could go for a second parameter, I could say also pass in distance. Okay. Oops. That's not the command I want. Let's just close those brackets up. Having one of those days today. Okay. Alright, yeah. Let's see if that works. Okay. It's not liking that second command there. So if I just want to arrange by speed anyway, that works. If I wanted to shift the sort, so make it descending, I could just do this, df, and then I could just pass in the descend parameter and just pass in my speed there. Now you can see that's reversed the order, and that's essentially how you sort elements in your data frame. To expand this out now, we're going to use the iris data set, because we need to start selecting by a categorical variable as well. That's only got numerical fields in it, so we're going to pass in we'll call it df2, and we're going to use the iris data set, good old reliable iris. So if I run that, you'll see that what this is this sepal length, sepal width, petal length and petal width, and it gives you a species for each one. So it's a classification task essentially, but which species they fit into. So now I'm going to use the select. It's a bit like a SQL select statement with DPLYR, select command. So I'm going to use select, and I'm going to use df2. I'm going to select by df2 species. Let's see what that does. Okay, species. So it just basically drops all the unnecessary fields. So if I just wanted as well the df2, I'm just going to see what the sepal length. It will create me another data frame as a subset of that, and it just keeps appending. Look, as you can see in the. If I then create this as a species by sepal length variable, this will show in my environment window. There. Okay, so I run that, and I've just got the fields then of interest. So I could perform some summary statistics on that. It's really powerful, the select command in DPLYR. DPLYR's also got a rename command, so you can rename based on a specific value. So I could use my iris data frame, or a copy of that iris data frame in df2, to relabel one of the species. Okay, let's do that. So we'll use the rename function. As you can see, it's a property of DPLYR. We're going to pass in the df2, which is our data frame, always data first. And then we're going to use df2 species. So where the species is equal to, and then we had Virginica, didn't we? So Virginica. No, this doesn't let you rename values, it lets you rename columns, sorry. So if I want to rename the species column, let's go back to the data frame, sorry, my mistake. So I want to call species new species or something like that. So if we call it new species equals species, it should then have renamed the column in that data frame. Okay. It's not an assignment operator. So now new species should be in my df2. Okay, what's happened there? Okay. Let's have df3 and it should be renamed in the new data frame. Okay. Okay. That's worked now. New species is against the old column name of species. Limited use, but it can be useful now and again. You can also use the distinct command, and I'm going to use that based on the iris data frame that we've created previously. But what this does is like a select distinct, it will return distinct values. So if there's repeated values, like we can see Virginica, 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 it will return the distinct values in that data frame. So what I've done is use the distinct, and then I've used a select command, passed in my data frame 2. Yep, and you can see there's multiple values against species, and then I've used the species column as the column to select distinct from. This is also useful for if you've got a list of a whole host of countries and you want to know the distinct countries within that. Okay, so that's relatively useful as well. You can also use the mutate command from DPLYR, which basically you can create calculated fields off other fields. You'll see what I mean in a second. So I can use mutate, and I can use my I'll use data frame 2 again. And we can create the new column, so mutated column, and then it's going to be equal to, let's say every sepal length take away every sepal width. No, sepal length take away petal length. Okay, so sepal length take away petal length. So what that'll do is use the data frame 2, which is my iris data set, and it will create a column called mutated column, and that will be equal to sepal length take away petal length. So you'll be able to see that in a second, but what we'll do is probably create that mutated data frame, just so we can store this in our data window. So it's there, lot, and we can see that actually if you take the sepal length, take away your petal length, it gives you 3.7. So that creates you a calculated field based on the original values. From that now, I can use another function called Transmutate, which will basically just give me everything just from that new column. So I'll use my Transmutate on my new data frame that I've just created. Transmute, and I'm going to use the mutated df, and I'm going to use let's create another new column equal to actually I can use the original data frame to force example home, so I'm going to call it trans column, and I'm going to that's going to be equal to, again, this command here, sepal length take away petal length. Let's see what that does. It should just return the single column. So if I could just take the head of that so I can see what it's doing. Top 6 records. Yep, so that's created essentially from our data frame 2, which is our original data iris. It's created a new column called trans column. It set that equal to the value of each row, so sepal length, so whatever the sepal length is there, take away the petal length. And it then, because it's transmuted, it returns just that single column, so the new column that we just created. So that's one, it's kind of an inverse of the mutate command. We can use the summarize command. Oops. This allows us just to drop down the original data frame, summarize, and just give me a summary. So we're going to use df2. I'm going to set a new column equals mean, mean width, sepal width. Equals the mean, so we're going to use the mean function, and we're going to use df2 sepal width. Just going to get rid of the notation there, just pass it directly through to that, and then run that. So that gives me a quick summary of what the sepal width is in that data frame. So we use df2, which is the original iris data set. We set a new column equals mean sepal width, and we set that to equal to the mean command of the sepal width. You have to also, if you want to remove null values, use the na.rm equal to true. So remove nulls essentially, and that will then run that. There's no null values in there anyway, but that's just worth knowing when you're doing summary statistics. DPLYR also helps you take samples from data sets. So again, we're going to use the iris data frame here. We can use the sample n command. We're going to pass in df2. We take a sample, and this uses a random sample of 20 rows. As you can see, it gives me a random sample of 20 rows. I could then just create that as a random sample of iris, and that's good for when you're doing summary statistics and you're testing interventions and stuff like that, testing experiments. So yeah, it's given me a random sample, and I've then stored that random sample in memory. So it's given me a random sample of those values. You can also use, there's another sample command that you can use, a fraction of that, give me a sample fraction. So we can use the df2 data frame, which is the iris data set. We can use the, just say what we want a sample size to be, say 0.05, 5% sample. We could use a 10% sample, which starts to increase a lot. Use a 15% sample, and we can use I just think there is a bootstrapping option here as well. Let me just have a look in help sample frac. Let's see if that comes up. Sample emerge from table, replace equals false. So we want to add, if we want to replace items in there, so with replacement kind of statistics, then we use the true command. So it puts the original values back into the random sampler and then could return those fractions again. So you might see values repeated here. But yeah, normally that's set as default to false, and it's for if you want to do bootstrap resampling and stuff like that, if you know what those are. We'll talk about some of that later on, but essentially that's how you can use the sampler fraction. So just to go over this again, because there's quite a lot that we've covered there. We used the cars data frame first. We looked at that and we created it as a data frame in memory. We used the filter command and we basically created another data frame from that, speed of 4 and greater than 2. So filter allows you just to generate a quick subset of that data. So we're my data frame where the speed is equal to 4 and the distance is greater than 2. We just showed you how convenient that is compared to looking at indexing. I looked at the slice command and how you can use that to slice your data frame. It just gives you the top 10 rows or whatever slice you want. The arrange command gives you the facility to sort your data frame very quickly. So we sorted by speed ascending, and then we use the descend command and pass speed in there to sort it by descending. We then looked at iris because we needed to look at more data that had also categorical variables in it, i.e. species. We looked at species by the length, so we selected a subset of that data. Yeah, so and then that stored that into memory. So just return the relevant values that we wanted. So instead of all 5 columns, we've just looked at 2 there. So we've looked at species and the sepal length. We use the rename command on data frame 2 to create a new column called new species. We assign that to data frame 3, and then we saw that the changes then took effect. So data frame 3, new species. We use the distinct command to select only distinct items from data frame 2 species. So that returned 3 values, which were setosa, vesicular and virginica. We use the mutate command to create a calculated field off our, and call it column, mutated column, off our original data in our data frame. So the sepal length take away the petal length. We use transmutate to perform an inverse of that, whereas that brings everything back. That brings just the column that you've mutated back. Summarize gives you quick summary statistics and drops down your data set. And then finally we looked at sampling. So we took a random sample of iris. We took 20 random numbers from data frame 2. We used the sample fraction, so we looked at 15% of our data frame 2. And then we looked at the replace command, which basically lets you do sampling with or without replacement. So think of marbles in a bag. When you draw them out, you can either leave them on the worktop and keep them out and not replace them, or you can put them back into the bag. So certain things this affects the probability outcomes, but we'll talk about that when we cover probability and statistics. Okay guys, that's a quick overview of DPLYR. There's a whole lot more functionality in that, but that should give you everything you need.